system, we can get a great health, right? What is the ultimate water? The water that lasts long, like Ganga water. We know a lot of things about water, right? Ganga water, water in Venezuela, water in different places. So water is full of minerals, tastes great, keep us free from diseases, refresh us whenever we do. That's an ultimate water. And trust me, friends, we are in the business of that water. Okay? So far, what are the sources of best known water? Ganga, we know in India, right? And unfortunately, it is dying, right? But still, this is one of the best known sources. There's a place called Hunza. This is in Pakistan occupied Kashmir, where there's awesome water, and people, their lifespan is around 120 years, right? 120 years, and women delivered babies at the age of, say, 90 years. People fathered kids at the age of 100 years, and this is all documented, right? And no one died with any unnatural death, right? So they have all died with the natural death. I'll talk about it more. Sources in many countries. Okay. So many scientists, many people, okay, they wanted to know about water. What is so different in Ganga water? What is so different in Hunza water? So there's a guy called Henry Conada, right? In 1930s, he traveled to Hunza. He stayed there in Hunza, right? And he wanted to know what is happening here. When he stayed there, he found people eat normal things. The environment is almost like, say, Germany, Switzerland, and other places. But their life is entirely different. No one is sick here. And he has used that water himself, and he found a very different level of health. So he started studying. He's known as the father of fluid dynamics in physics. He invented Conada effect, on which Jet 747 has been developed. Now he was also in the team of Wright brothers who developed airplane, right? So this man, he has said a very famous sentence: "You are what you drink." Right? It is not Johnny Walker, but it's a water he was talking. Then he died. He did a lot of things. He wanted to make that water in lab for domestic use, right? In India and in Asian countries, the problem is, like, if something is very good, we started praying it. So we pray Ganges, we don't preserve it, right? When he came here, he stayed. He said, "Okay, I'll work. I would like to understand what is the principle. We'll make it for domestic use so the whole world can use it." Now he died, and he handed over all his research to a guy called Patrick Flignan and Gail Crystal, his wife. They worked 20 years in their lab to create Hunza-like water. Okay? And finally, they had created that water they named as structured water. Now, Biodisk also made structured water. Okay? Whatever hard work they have done is basically, we have used the same technology in Biodisk. Okay? But they are the first people who understood this fact that water is different. Now H2O, both are H2O, okay? But there is some difference between that water and this water. Now, which was very difficult at that point of time. Even now, when I talk to some of the professor of chemistry and I say that this water is very good structured water, is what? Can you change the molecular structure of the water? No, we are not doing that. No, it doesn't work. I don't know what you're talking, right? Still. So this is how it is. When these people, they have made this thing, now this was available to the world, then many groups of scientists were working. Yeah. were working towards to develop, to understand this water and all. Okay? So there was a group of scientists, Dr. Ian Linus, right? We all know, we have seen him in the Weekon, right? So he developed a miniature version of that thing which they have made. Okay? They made vivifiers which are to energize the water and all that. So biodisk is a miniature form of a vivifier. Vivifier, अगर हिंदी में बोले तो जो जीवन प्रदान करे या किसी चीज को जीवन बना दे, that is vivifier. So vivifier was a machine which was initially developed in Hamburg University to energize the water. Okay, and Dr. Jan Linus understood that and he created it. Now, in a short term, right? People have gone there in a many group of scientists. They visited different places, right? In Ecuador, in Venezuela, in India, and they found the quality of water is the property of the place, not the property of water. Special places have got different stones which have got different minerals, and that mineral energy is there. Now, when water crosses that mineral energy, that energy energizes that water, and that's why this water is different from the normal distilled water, or chemical, or a clean H2O, right? So biodisk is made up of 14 technically engineered minerals fused together using 3000 degrees C. So when we went there, those places, they found these stones are there. They've taken the samples of those stones and they said how we can replicate those stones in the lab. So those samples have been analyzed, but they found that it is not possible to recreate them in a lab in a normal fashion. Why? Because these stones are around 3,000 4,000 year old stones, right? कभी ज्वालामुखी फटा होगा, लावा बहा होगा, उसका solidification हुआ होगा, right? So it's a natural creation. It cannot be copied so easily. So they said, ठीक है, we will create similar situation. We will find a material जिसको हम 3000 डिग्री पे गर्म कर सकते हैं. और 3000 डिग्री पे इन minerals के साथ, they have understood the mineral composition of different places, so they have made an ideal mineral composition with around 13-14 minerals, and they have fused it with the help of nanotechnology at 3000 degree. Now this glass is a very special glass, okay? This is being manufactured by the company called Schott AG. Schott AG is a 125-year-old organization which is one of the best glass company, which is also the subsidiary of Carl Zeiss Foundation. I'm sure you all know Carl Zeiss,
Yes.
right? So Carl Zeiss Foundation has got two companies. One is Schott AG, another is Carl Zeiss AG, right? Now Schott AG make glass for high precision application like spaceships. So they give glass to NASA, right? And many other high precision, highly scientific applications. So they said